Welcome to the second video on linear systems. This is part 2. In the first one, we talked about the substitution method, which is one way of solving a linear system, which is two or more lines. And we're finding points of the point of intersection. And in this one, we are going to go through the elimination method. In the elimination method, your steps are to multiply one or both of the equations so that one variable's coefficients are opposites. Now that's a lot of big words in there that we need to make sure that we know the definitions to, so that we can actually go through this procedure. So we know that variables are the letters. Okay. So it's one of the variables' coefficients. Now coefficients, remember, are the numbers in front of the variable. So the numbers in front of the variable. So if it's a 2x, 2 is the coefficient on x. If it's 2x minus 3y, the 2 is the coefficient on x, and negative 3 is the coefficient on y. And we want those coefficients to be opposites. Opposites, remember, are the same number, but one's positive and one's negative. And the reason that we want opposites is, if you think about it, if I have a 2x and a negative 2x, what happens when I add those? 2x plus a negative 2x would be 0x, and 0 times anything is 0, which means that variable x would eliminate. Thus, it's called the elimination method. So we're going to multiply one or both of the equations to get one of the variable's coefficients. We don't need x and y, just either x or the y coefficients to be opposites. And so we're going to manipulate the equations so that we can get them that way. And we're going to do that by multiplying the equation, or both equations. Then you're going to add the two equations together, and that, like I said, when we add opposites, it eliminates that variable. And so we'll be back to one variable, which we can solve, and we can do the same steps that we did in the previous method. We can back substitute to find our second variable, and then always check to make sure that we have it correct. So here's my first example. We have 7x plus 2y equals 24, and 8x plus 2y is equal to 30. Now, if we were to eliminate x's, we would have to multiply both equations so that we could get opposites. Now the first multiple, remember when we learned our multiplication tables, those were multiples. So like the multiples of 5 would be 5, 10, 15, 20, 25, 30, etc. So the first multiple that 7 and 8 share is actually when they multiply together, and you get 56. So if I was to eliminate x's in this example, I would need to multiply the first equation by an 8 and the second equation by a 7. And one of those would have to be negative, because notice that both of my variables, or both of my coefficients on x, the 7 and the 8, are positives. So I need to get one of them to be a negative. So I would have to multiply one of them by a negative to change the signs. That's big numbers that we have to multiply. Multiplying by 7 and multiplying by 8. So I'm going to look at my y's and see if maybe that's easier. Now on y's, it's really awesome because the coefficients are the same. The coefficients on the y's are both 2's. So that's awesome. However, I need one of them to be a negative 2 so that I can cancel them, or that they cancel out when we add them together. So I just need to change my sign from a positive to a negative. In order to do that, we just multiply through by a negative 1. Now I have to decide, do I want to multiply the top equation by negative 1 or the bottom equation by negative 1? Well, this is where I want to work a little bit smarter and not so hard. So I'm going to look at all my other numbers and see which one would be better to have negatives. Remember, when we multiply by a negative 1, we're multiplying every term on both sides of the equal sign by that negative 1. That's the only way that it keeps it the same equation, just looking different. And so when I multiply by that negative 1, it's going to change all of my signs. So if I change all of the signs in the first equation, I'd have a negative 7x, and then I'd be adding 8x to it. 7 is smaller than 8. I'd rather have my smaller numbers be negative. If I multiply the second equation by that negative 1, I would have had the negative 8x plus 7 that would have given me a result that's negative, and then I might make a mistake later. So it's going to be easier and more beneficial to me if I multiply the top equation by the -1. So that is the first step, is to multiply one of the equations, or both. In this case, I only had to multiply the 1 equation by -1. I'm going to write the new equation over here on the side. And again, multiplying by a -1 just changes my sign. So I end up with a -7x minus a 2y is equal to a -24. Remember, the only way that this is true is if I do the same thing to both sides of the equal sign. So both sides are being multiplied by -1, which means every term is going to be multiplied by -1. I'm not going to change anything in my second equation. As stated before, I already had the same numbers, so I'm just going to rewrite that underneath. Now, the key point that I should have mentioned a little bit earlier in the elimination method is that you really want to make sure things are lined up. Everything should be in standard form. Let me go back and write that over here. So back in standard form here for the elimination method, I really want to have x's and y's on the same side. So my first equation I want to have in the form of ax plus by equals c. And the second equation I want in the form of dx plus ey is equal to f. Okay. Notice how the x's are above the x's, the y's are above the y's, the equal signs are above the equal signs, and your constants are above the constants. We make fewer mistakes in the elimination method if we stay neat. Neatness counts. Because we can only add x's to x's and y's to y's, so we want to make sure that they're lined up nice and evenly for us, and that we don't miss any signs and we don't get lost in the chaos. So going back over here, I want to rewrite the second equation just as it is, lining things up. X under x plus 2y is equal to 30. And that's the first step. The second step is to now add those equations together. -7x plus 8x is 1x. I technically don't need the 1 in there, but I'm just showing all my steps in this problem. -2y plus 2y is 0y. 0 times y is 0. So whoop-ch, it's eliminated. -24 plus 30 is the same thing as 30 minus 24, and that's giving us a 6. So just like that, I've eliminated one of my variables, and now I can solve for the other one. Now technically, 1x is the same thing as x equals 6. If I had a different number there, I would have to divide by that number to get x alone. So that's a little bit harder is to do the setup, but the actual solving then of adding the two equations together is actually and usually a lot easier than in the substitution method, where you have to use your distributive property, combine like terms, get the variable on one side and the constant term on the other side, and divide to conquer. That has many more steps to it than the elimination method. However, the elimination method in the beginning here has a little bit more work, as we have to think about what we are multiplying and which equation we're multiplying it to get the setup. It is going to be a little bit more complicated at this point. We now have to find y. Now, this is where the substitution method definitely is easier, because remember, in the substitution method, we would have had an equation that was y equals blah, blah, blah. And so you stick the x in that blah, 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 and you simplify. Here, x and y are both on the same side, the equal sign, which means that when I substitute x in for the 6 in for x in one of my equations, I have to solve for the y, which means I'm going to have to do a few more steps. It's still not as many steps as using the distributive property and combine like terms, etc. on there, but it is a two-step process that we're going to have to go through. Okay. So it does not matter which of your original equations that you go in and check. I'm going to go into that second equation just because I'm more comfortable with even numbers than I am with that 7. I might make a mistake there. But again, it does not matter which of the original problems you go in to check. Okay? So I'm going to go into that second one, and it's 8 times that x value plus 2y is equal to 30. So again, I'm just substituting the value of 6 in for x. And now I get to simplify. 8 times 6 is 48. I still have plus 2y is equal to 30. Now I need to get the variable term by itself, so I'm going to move that 48 to the other side by subtracting it. 48 minus 48 is 0, so it goes away. 2y is equal to negative 18. Remember, one of each sign you subtract and keep the sign of the number that's further from 0. And then finally we divide to conquer. So we get y is equal to negative 9. Now again, we checked our answers. Absolutely no reason to get these wrong because you can check every single one to make sure that it's right. I solved for y by using the second equation. So I don't have to use the second equation. I have to use the first equation. Just like in the previous method, in the substitution method, you solve for that second variable using one of your equations. So you really only have to check in the other equation that you didn't use. So going into that equation, it's going to be 7 times my x value of 6 plus 2 times my y value of negative 9 is equal to 24. Now just simplify. 7 times 6 is 42. 2 times a negative 9 is a negative 18 is equal to 24. Does 42 minus 18 equal 24? Well, let me show my work. I can't take 8 from 2, so I borrow. Neighbor, may I have a cup of sugar? Sure, honey. So the 2 becomes a 12 because I add 10 more to it. 12 minus 8 is 4. 3 minus 1 is 2. Yay! 24 is equal to 24. It checks. So again, I can then write my solution, x first, then y, in parentheses, otherwise it's not a point. Now that problem was pretty easy because my coefficients were already the same number. So all I had to do was multiply by a negative. What happens if they're not the same number? So in my next example, I have negative 4x minus 2y is equal to 14. And I have negative 10x plus 7y is equal to negative 25. So again, I'm just going to walk through my thought process as to how I determine whether I want to eliminate x's or eliminate y's. So I first look at my coefficients on x. I have a negative 4 and a negative 10. I like that they're both even numbers because even numbers seem to have common multiples a little bit sooner. I know where to go with that. I know my multiplications of even numbers a little bit better. But they're not the same, and I have the same sign. So once again, even though they're both negatives, I would have to multiply one of the equations by a negative so that I would have opposite coefficients, one positive, one negative. And the first multiple that 4 and 10 share would be 20. So I'd probably multiply the top equation by a negative 5 and the second equation by a 2 to get a negative, or to get 20x and a negative 20x respectively. That's not too bad. It's definitely doable. I'm good at multiplying by 5s and multiplying by 2s, so that would work fine. But let me go and look at the second set of variables, coefficients. So on my y's, I have a negative 2 and a 7. So what I like here is that they already have opposite signs. So I don't have to multiply by a negative in order to get opposites. I still have to multiply both of them by some other number. Now the first multiple that 2 and 7 share happen to be when you take 7 times 2 or get 14. So to eliminate y's, I'd have to multiply the first equation by 7 and the second equation by 2. I'm not too bad at multiplying by 7s and multiplying by 2s, so that's definitely doable. However, I think multiplying by 5s and 2s are a little bit easier. So I'm going to show how to multiply and eliminate x's just because I want to show some of those different techniques. Okay? Again, it would not matter which one you choose, it just determines which variable you solve for first. Okay? So like I said, on this one, I'm going to eliminate x's. And so I'm going to multiply this top equation by a -5. And in part, I chose that to have the negative because that equation already had two negatives, the -4x and the -2y. So multiplying that by another negative is going to make it positive. In addition, on the bottom, it would make my variable or my coefficient on my other variable y positive. I'd rather have that positive than negative. Whereas in the second equation, if I multiplied that by the -2 instead, it would make my coefficient on y negative, and then I might make a mistake. So I'm multiplying that one by a -5 and this one by a +2. Now, every term in that first equation is multiplied by a -5, and every term in the second equation is being multiplied by 2. That is key. You can't just pick and choose what you multiply. It's all or none. So -5 times -4x is going to give me a +20x. -5 times a -2y is a +10y. And then -5 times 14 is a -70. In my second equation, I'm multiplying just by 2. 2 times -10x is going to give me a -20x. Remember, we needed that because those are opposites and they will eliminate. 2 times 7x is a +14y. Sorry, 2 times 7y is equal to 2 times a -25 is going to give me a -50. Now our next step is to add those equations together. One of your variables will eliminate. If it doesn't, you did something wrong. 20x minus 20x, whoop-ch, eliminates. 10y and 14y is now 24y. Oh, that's a big number. That's all right. -70 and a -50. They're both negative, so you keep the signs and you add them, and you get 120. And now to solve, you're going to divide to conquer. And you end up with y is equal to -5. So again, we just found y. We still need to find the x that goes with that. So I have to go into either the first or the second equation to do so. Again, it does not matter which one I go into. I think I'm going to go into the second one because dealing with tens are pretty easy. 10, 20, 30, 40, that's pretty easy to deal with. So I'm going to go into that situation first. But again, it should not matter which one you plug into. You'll get the same answer either way. And now I'm replacing the y with the y that I just solved for, which is -5. Do a little cleanup here. Positive times a negative is a negative. And I have to move that to the other side, so I'm going to add the 35. -25 plus 35 gives me a +10. And dividing to conquer then, dividing by the -10. X is equal to -1. Finally, we check. And again, I got the x is equal to -1 from the second equation, so I have to check in my first equation. -4 times the x value minus 2 times my y value will equal 14. Now I simplify. Negative times a negative is going to give me a +4. In the next one, it's also a -2 times a negative 5. So that also is going to give me a positive 10. And 4 plus 10 is 14, so the left side does equal the right side. So again, we can then write our solution in alphabetical order, -1, comma, -5. So although you could only, possibly, it is possible for you to only learn one of the two techniques, it's one of those situations in which, depending on the numbers that are given, you might want to use one method over the other. So it's good to have both tools in your toolbox, or your tool belt, that you know how to solve for both. I would not only solve for substitution, because sometimes in those substitution problems, you would end up getting fractions if you try to solve one of the equations for one of your variables. That's why it's nice to have a second method like elimination in order to solve and not have to deal with those frickin' fractions. Okay. So that is your elimination method. You have to multiply one or both of your equations so that when you add, one of your variables will cancel because the coefficients are negatives. In the next one, we are then going to go through a system in which it has 3 equations with 3 variables. And so we're going to use the elimination process not once, not twice, but 3 times. And we really need to make sure that we keep things organized for that process. So practice them with the 2 variables before you go on to 3.